Henry "Smokey" Yunick, a legend rewriting the rules of racing. In the midst of the global fuel crisis of the 70s, he unveiled an engine capable of traveling 250 miles on a gallon. Yet the world, gasping from the oil famine, inexplicably rejected it. Officially, his invention was too dangerous, too complex for mass production. But Smokey himself, a visionary and a rebel, saw a different truth. His genius threatened more than just old engines. It threatened to collapse billion-dollar empires, oil giants, auto manufacturers, unprepared for tectonic shifts. So what truly suffocated Yunick's hot vapor? A lack of genius, or an excess of self-interest? This saga of a breakthrough rejected by the world forces us to ponder the true cost of innovation. In the pantheon of racing gods, there's a special niche for those who didn't play by the rules, for those who rewrote them. Henry "Smokey" Yunick isn't just a name. He's a legend carved at the edge of what's permissible. He was more than a mechanic, more than an engineer. Smokey was a devil in the details, a virtuoso of loopholes, a man who saw the invisible and heard the inaudible in the roar of an engine. His intuition was prophetic, his mind sharp as a razor. He was a seer whose genius often bordered on madness and whose innovation bordered on outright rebellion. For him, rules were just a starting point, not a finish line. Welcome to the best damn garage in town. Here, in Daytona Beach, Florida, amidst the smell of gasoline, hot metal, and sweat, magic was born. It wasn't just a workspace. It was the headquarters of the engineering underground, a legendary place where Smokey Yunick transformed ordinary cars into unstoppable monsters of speed. The walls of this garage seemed to have absorbed thousands of solutions, hundreds of audacious ideas, born in disputes with NASCAR officials. Smokey could stretch a car's chassis by an inch without altering its declared length. He could hide an extra gallon of fuel in the roll cage tubing. His methods were so unconventional, and his ability to find advantages so unprecedented, that Smokey Yunick's name became synonymous with unconventional thinking that challenged authority. He was the one who always saw the world from a different angle. But while Smokey was breaking rules on the racetracks, the world was rapidly changing. The 1970s arrived, and with them, the shadow of a global energy crisis. An oil embargo, empty gas stations, skyrocketing fuel prices. What seemed unshakable suddenly faltered. The economy was suffocating, and the automotive industry stood on the brink of disaster. The search for fuel efficiency transformed from an academic interest into an urgent, almost desperate need. Every liter of fuel was now worth its weight in gold, and the need for a breakthrough was sharper than ever. It was at this moment of universal despair and searching that Smokey Yunick's genius extended beyond the racetrack. From his legendary garage, where the spirit of innovation seemed to linger, a whisper emerged. A whisper about a solution capable not just of optimizing, but of fundamentally changing fuel consumption. It was the hot vapor engine, a daring, almost heretical concept that promised to save the world from fuel starvation and forever rewrite the laws of automotive engineering. Smokey didn't just modify existing systems, he proposed an entirely new philosophy. At the heart of this revolution lay an idea, simultaneously simple and ingenious. Gasoline should burn not as a liquid, but as a vapor. Forget traditional carburetors or injectors, which atomize fuel in droplets. Yunick proposed fully vaporizing gasoline, heating it to an incredible 150 to 200 degrees Celsius, even before it entered the combustion chamber. Imagine, not droplets, but pure, weightless, homogeneous fuel vapor. This superheated gas was then mixed with air, forming a so-called lean mixture that was fed into the cylinders. This was a fundamentally different approach, promising complete and efficient combustion. And the results Smokey demonstrated were astonishing. He claimed his engine achieved thermal efficiency of 50%, and sometimes even higher, up to an incredible 60%. This was more than 2, and sometimes even 3 times better than standard engines of that era, whose figures rarely exceeded 20 to 30%. High temperatures and ideal mixture homogenization ensured that every fuel molecule combusted as completely as possible, minimizing losses and harmful emissions. In those years, when every gallon counted, such figures sounded like science fiction. Rumors spread like wildfire. It was said that his modified Pontiac Grand Prix could travel an incredible 250 miles on a single gallon of fuel, equivalent to approximately 106 kilometers per liter. Of course, skeptics immediately disputed these figures, considering them an exaggeration or the result of unrealistic conditions. But one thing was clear. Smokey Yunick, this uncompromising maverick, showed the world potential that exceeded the wildest expectations. He wasn't just a racer or an engineer. He was a visionary who dared to challenge established notions. While major automakers played it safe, optimizing existing technologies, Smokey Yunick was building the future in his own garage. His hot vapor engine was more than just a technical innovation. It was a manifesto against inertia, a prophecy of an alternative path capable of forever changing the automotive industry. But such revolutionary ideas are rarely accepted without a fight. And in this story, as we will see, behind the whisper of promises lay a thunderous conflict that could cost Smokey everything. After the world was introduced to the audacious idea born deep within the best damn garage in town, it's time to reveal its essence. Smokey Yunick, this alchemist under the hood, didn't just speak of a new philosophy. He built it, piece by piece, as if embodying forbidden knowledge. His hot vapor engine wasn't merely a modification, but a challenge to the very nature of combustion, an attempt to cheat entropy and extract the maximum from every drop of golden fuel. Every liter of gasoline was destined for an alchemical transformation. In Yunick's system, fuel didn't enter the cylinders as fine droplets atomized by a carburetor or injector. No, it underwent a far more radical transition. Gasoline was first directed into specially designed heat exchangers, where it was heated to an astonishing 150 to 200 degrees Celsius. At such temperatures, and under pressure, it completely vaporized, ceasing to be a liquid and transforming into a pure, superheated, perfectly homogeneous vapor. Imagine not a mist, but absolutely transparent, invisible gaseous fuel, devoid of the slightest liquid impurities. It was this hot, homogeneous vapor that held the key to the breakthrough. It was then mixed with a much larger volume of air than in conventional engines, creating a so-called lean mixture. This wasn't merely less fuel for more air. It was an ideal molecular combination where every fuel particle was uniformly distributed within the air mass. In a traditional engine, even with the most precise injection, areas of varying mixture concentration inevitably arise, leading to incomplete combustion. But Yunick's system eradicated this problem at its root, ensuring that every fuel molecule found its oxygen molecule for a perfect reaction. It's no wonder some called his invention the lean burn engine, a super lean mixture engine, or even a fouled plug engine, hinting that ordinary spark plugs would behave very differently here. And the results of this engineering magic were astonishing. While production engines barely reached 20 to 30% thermal efficiency, with most energy simply escaping as heat, Yunick claimed his brainchild easily achieved 50% and sometimes an incredible 60%. This wasn't just better, It was a multifold superiority, promising to turn the entire industry upside down. He didn't just promise, he showed. The theory behind these figures was crystal clear. Complete and uniform combustion of the homogeneous vapor-air mixture meant that practically no unburned hydrocarbons remained, the bane of conventional engines. This minimized energy losses that typically go into heating the environment and expelling unused fuel in the exhaust. Furthermore, cleaner combustion meant fewer deposits on engine parts, potentially increasing its lifespan and reducing maintenance costs. It was an engine that not only saved gasoline, but also ran cleaner, more efficiently, literally squeezing the maximum out of every energy impulse. For those who doubted, Smokey didn't just wave figures around. He demonstrated his prototype. Specialists from the Society of Automotive Engineers, SAE, the most authoritative minds in the industry, saw this engine in action with their own eyes, researching its performance. And, most importantly, they confirmed its functionality and claimed efficiency. This was no garage myth. It was proven technology, confirmed by leading experts. But what truly ignited the public's imagination and fueled the legend was the rumor of phenomenal mileage. It was said that his modified Pontiac Grand Prix, equipped with this miracle system, could travel a fantastic 250 miles on a single gallon of fuel. For comparison, at that time, 20 to 30 miles per gallon was considered a decent figure. 250 miles. That was like flying to space on a jetpack, a promise of complete freedom from the fuel crisis. Of course, skeptics immediately pointed to possible exaggeration, to ideal testing conditions that couldn't be replicated in everyday life. But the figure was named, and it was forever etched into public consciousness, becoming a symbol of what this uncompromising visionary was capable of. Smokey Yunick's hot vapor engine was more than just a mechanism. It was a challenge to the status quo, a manifesto against limited thinking. It showed that a world gasping from oil famine could be saved by a single ingenious idea, embodied in metal. But, as is known, revolutions rarely go smoothly. And the next chapter in this story will show that for Smokey Yunick, his prophecy turned not into glory, but into the beginning of a real war. But triumph, as is often the case, proved to be a fragile mirage. After SAE specialists witnessed the functionality and efficiency of this engineering masterpiece with their own eyes, after the world held its breath awaiting promised breakthroughs, silence fell. A deafening, frightening silence in which Smokey Yunick's entire revolutionary idea slowly but surely drowned. What then halted this wave of progress? The official reasons were stated, and they sounded like a verdict. The main obstacle erected in the path of the hot vapor engine was the word danger. Did the very heart of this innovation conceal a mortal threat? Imagine gasoline, heated to 150 to 200 degrees Celsius, transformed into superheated pressurized vapor. Now imagine an accident, a collision. What would happen if this invisible, super flammable gaseous concentrate escaped? An explosion, a fire instantly engulfing everything around it. Unlike conventional liquid fuel, which spills and slowly evaporates upon leakage, hot vapor would be like a ready-made time bomb, or rather, an instant action bomb. The risk was unacceptably high for mass production, where the safety of 1 million cars outweighs even the most brilliant economy. Beyond this sword of Damocles of danger, there was also the cold, calculated pragmatism of engineers. Smokey's system, for all its genius, proved to be remarkably complex. To transform liquid into hot vapor, additional heat exchangers were required, essentially small reactors integrated into the engine's exhaust system to utilize the heat of spent gases. Then came the need for high-precision pressure and temperature control systems, capable of instantaneously reacting to changing operating conditions. And of course, specialized injectors, capable of working not with liquid, but with pressurized gaseous fuel. Each of these elements added a new layer of complexity, increasing production cost, making maintenance more expensive and demanding, and the engine itself less repairable. And even if danger and complexity could somehow be circumvented, what about daily routine? One of the most obvious practical obstacles was cold engine starting. For the system to work, gasoline first needed to be heated to vaporization temperature. This meant that simply turning the key and driving off, as we are accustomed to, was impossible. A driver would have to wait until the system reached the required temperatures, and these were precious minutes, incompatible with the dynamic pace of modern life and consumer demands. What buyer would agree to wait 5 to 10 minutes every morning before their car would move? And finally, in those years, when the world was just beginning to grasp the scale of environmental problems, theoretical questions also arose regarding the hot vapor engine. Yes, thanks to the complete combustion of the lean mixture, emissions of unburned hydrocarbons and carbon monoxide, the main scourges of traditional engines of that era, were significantly reduced. This was a colossal plus. But here's the paradox. The extremely high combustion temperatures that provided such efficiency also had a downside. They could lead to a significant increase in the formation of nitrogen oxides, or NOx, another, no less dangerous pollutant, contributing to smog formation. To address this new problem, even more complex and expensive exhaust gas after-treatment systems would be required, which again diverted the technology from the idea of a simple and affordable solution. Thus, the official version stated, Smokey Yunick, for all his genius, had created a mechanism too dangerous, too complex, and impractical for mass implementation. Too many ifs, too many compromises. But were these the only reasons? Or did something more lurk behind the official statements, like a whisper of wind in an empty garage? Smokey himself, a man who had challenged authority and rules his entire life, treated these official explanations with disdain. He saw them as a convenient shield, covering far more prosaic and cynical motives. After all, his engine, promising a fantastic 250 miles per gallon, threatened not just to change the industry, it threatened to collapse the foundations of a multi-billion-dollar market. Imagine, if cars started consuming 10 times less fuel, what would become of the oil giants? And of the automakers, whose production lines were geared towards manufacturing complex, yet long-mastered designs? Rumors that Yunick personally offered his technology to major automotive corporations and received rejections under various, sometimes absurd pretexts, only added fuel to the fire of these conspiracy theories. Yunick's unconventional and uncompromising nature, his propensity for confrontation with the establishment, including NASCAR, could also have played a role. Perhaps the large corporations simply didn't want to deal with such a difficult genius, preferring to work with more systematic and predictable engineers. Thus, the hot vapor engine became not just a technical curiosity, but an archetypal example of how breakthrough technologies, capable of changing the world, can be rejected or delayed due to a whole complex of economic, political, and structural barriers. The dream of hyper-efficiency shattered against risks, costs, and systemic resistance. But even in its oblivion, the operating principles of this remarkable engine, the pursuit of improved vaporization, mixture homogenization, and lean combustion, continue to live on. They became the foundation for research that, decades later, led to the emergence of modern technologies like direct fuel injection engines, Smokey Yunick lost the battle, but his ideas outlived him. However, for him personally, this was not just a defeat on the engineering front. It was the beginning of a real war. A war he waged until the end of his days, and which we will tell you about in the next chapter. So, the official version was voiced: danger, complexity, impracticality. Convincing? Perhaps, but only for those who never looked behind the curtains of big money and big politics. Because behind this screen, like shadows on a cave wall, far more ominous motives loomed. Motives capable of burying any, even the most brilliant innovation, if it threatened the powerful status quo. Imagine not just an innovation, but a tectonic shift. An engine that promised astonishing figures. Some claimed up to 250 miles per gallon. Others spoke of colossal, up to 60% thermal efficiency, which doubled anything then in existence. If even half of these figures were true, it would mean disaster for the established world order. Oil giants, whose super profits were built on humanity's insatiable thirst for fuel, would suddenly face a collapse in demand. Billions invested in oil extraction, refining, logistics, thousands of jobs worldwide. All of it would hang in the balance, like a house of cards before a hurricane. In the 70s, when the world was already experiencing the shocks of oil crises, the need for efficiency was sharper than ever. It would seem such a breakthrough should have been a salvation. But paradoxically, it was this acute need that could become a death sentence for Yunick. After all, localized supply problems were one thing, but a fundamental reduction in global consumption that threatened to redraw the entire world economy was quite another. For those who controlled the flows of black gold, the idea of an engine running on mere sips of gasoline was not a blessing, but an existential threat. This wasn't just a loss of profit. It was a loss of power, a loss of control over one of civilization's main arteries. And what about the automotive manufacturers? Imagine Ford, General Motors, Chrysler, companies whose assembly lines ran like clockwork, honed for decades to produce millions of cars with traditional engines. Implementing Smokey's technology required not just modification, but a fundamental overhaul of the entire production cycle. This would mean colossal investments in new lines, retraining engineers, a complete change in spare parts logistics. This wasn't just a model refresh. It was as if someone proposed to completely redesign the internet tomorrow, abolishing all existing protocols. None of them were ready for such a disruption. Old business models, built on decades-proven technologies and predictable demand, would collapse overnight. It was simpler and more profitable to maintain slow, controlled evolution than to embark on a revolution that threatened the entire foundation of their empires, requiring trillions of dollars in investment and disrupting decades-established supply chains. And this is where Smokey Yunick himself entered the scene. A legendary figure whose name was synonymous with uncompromising defiance and brilliant rebellion. Henry Smokey Yunick, mechanic, engineer, racing innovator, whose workshop, the best damn garage in town in Bunnell, Florida, was not just a garage, but a temple of automotive magic and defiance. He didn't play by others' rules. He always found loopholes, bypassed them, and sometimes even wrote his own on the back of dirty napkins, then embodied them in metal and speed. It was this skill that gave him an advantage on NASCAR racetracks, allowing his drivers to win, often on the verge of foul play. But it also made him extremely inconvenient for large corporations, for the world in suits and ties. Smokey, confident in his brainchild, knocked on Detroit's doors. He personally offered his engine to major automotive corporations. The answers were polite but firm. and although they often cited the already mentioned dangers or technical complexities, cold start problems or maintenance difficulty, which we discussed, Yunick saw these as merely convenient excuses, a facade behind which lurked an unwillingness to change the accustomed order. He knew his engine was too good, too efficient, to be accepted painlessly. His sharp tongue, his readiness to confront any authority, whether NASCAR officials who often scratch their heads over his wrong-right cars, or the CEOs of auto giants, only exacerbated the situation. The corporate world, where decisions are made by committees, where they prefer to work with predictable and system-oriented engineers who don't question the status quo, simply couldn't accept such a lone rebel. Smokey was too independent, too vociferous in his accusations, and too insistent in his demands for radical change. He was a hurricane that threatened to destroy not only old engines, but entire financial ecosystems built on consumption. And, as often happens, the system preferred not to change, but to isolate, to push the threat into the shadow of oblivion. Thus, the hot vapor engine became not just a symbol of missed opportunities, but living proof of how the most revolutionary ideas can be stifled not by a lack of genius, but by an excess of self-interest. This is a story of how a bold visionary encountered an insurmountable wall of oil, steel, and billions of dollars, a wall that could not be breached by logic or engineering genius. Smokey Yunick understood this. He knew he hadn't lost an engineering battle, but a war with the system. And this war, which we will tell you about in the next chapter, was just beginning, gaining momentum in his indomitable soul. The war with the system, as Smokey called it, was lost, but the questions remained. This battle didn't erase his engine from history. On the contrary, it sealed it into legend. And now, we must separate the glittering myth from the steel mechanics. So what does this saga of hot vapor truly tell us? Let's start with the most astonishing claim, the one that made hearts beat faster and skeptics nervously smirk. 250 miles per gallon. Sounds like utopia, right? Like a promise written on desert sand. But let's look under the hood, into the very essence of what Yunick did. He didn't just modify an engine. He reinvented the way fuel was burned. A traditional engine injects liquid gasoline, which is then atomized and mixed with air. But with Smokey, everything was different. His hot vapor engine was a harbinger of the future, operating on principles that then seemed like magic, but today, fundamental science. The essence was complete vaporization. Gasoline, this liquid and wayward energy source, before entering the cylinders, was heated to a colossal 150 to 200 degrees Celsius. It transformed into a pure, homogeneous vapor. Imagine, no droplets, no uneven atomization, only an ideal, hot mist, which was then mixed with air into an extremely lean, yet absolutely homogeneous mixture. Such a mixture combusted remarkably completely, leaving minimal unburned residues and wasted heat. It was this, according to Yunick's claims, that allowed for astonishing thermal efficiency of 50 or even 60%, which was 2 and even 3 times higher than the figures for production engines of those years. And here we come to the dilemma of 250 miles per gallon. Was this figure realistic for the average driver? Most likely no. But could Smokey have achieved it under specific, controlled testing conditions, in a specially prepared car, with ideal tuning and at certain speeds? Quite possibly. It wasn't a lie, but rather an exaggeration that became a symbol of untapped potential. Like a flash of lightning illuminating the horizon of possibilities, but not becoming a constant light. And what did the engineering mind say about this? This question is critically important. After all, If Yunick's engine had been merely a rebel's fantasy, it would have long been forgotten. But no, Smokey wasn't a lone madman in a garage. He demonstrated his prototypes, including the modified Pontiac Grand Prix, to respected specialists, and most importantly, the Society of Automotive Engineers, SAE, not some conspiratorial organization, but an authoritative voice in the industry, confirmed the functionality of his engineering masterpiece. They saw its potential. They knew it worked. So why then, if even serious engineers confirmed its viability, did this breakthrough not go into mass production? The official reasons sounded convincing. The first and foremost, excessive danger. Imagine gasoline heated to 200 degrees and under pressure in a vaporous state. In the event of an accident, this would not just be a leak, but a potential firestorm, an explosive bomb. The safety risks for consumers were colossal. Then came complexity. This engineering feat required highly complex heat exchangers, precise temperature and pressure control, specialized injectors capable of working with vapor. All of this meant a sharp increase in production and maintenance costs, transforming a simple engine into a high-tech unit requiring special care. And of course, the famous cold start problem. Vaporizing the fuel required time, preheating. This meant you couldn't just get in the car and drive off, as we are accustomed to. In everyday life, such an engine would be unacceptable. And finally, environmental concerns. Although complete combustion reduced emissions of unburned hydrocarbons and carbon monoxide, the high process temperatures could paradoxically increase the formation of nitrogen oxides, NOx, which would require additional, then still underdeveloped, emission control systems. These technical barriers, in conjunction with the incredible economic and political reality we've already discussed, became an insurmountable wall. It wasn't just one of, it was a whole complex of problems. But what if this wall had collapsed? What if engineers had found a way to circumvent the risks, simplify the design, and solve the cold start problem? Imagine a world where Yunick's engine became the standard, a world where every car consumed 2 or even 3 times less fuel. This wouldn't just be gasoline savings, it would be a tectonic shift. Firstly, it would mean a revolution in energy. Dependence on oil would sharply decrease. Countries that had battled for decades over control of oil fields could breathe more freely. The geopolitical landscape would be unrecognizable. Oil giants, their influence and power, would be reduced to a minimum. This wouldn't just be a threat to their profits. It would be an existential threat to their existence, their centuries-old status. Secondly, it would change the automotive industry itself. Cars would become more affordable to operate. People could travel more and cheaper. Implementing such technology would require colossal, but justified, investments in new production lines, staff training, and the creation of new service infrastructure. And this would have happened in the 70s, at the height of oil crises, when the world was gasping from fuel shortages. Yunick's engine could have become not just a salvation, but a catalyst for a new era, an era of sustainable development and energy independence. And ecology. If the NOx problem could have been solved, the air in our cities would be significantly cleaner due to more complete combustion. Metropolises could breathe freely, and nature recover from decades of industrial impact. But this dream remained just that, a dream. The truth, as often happens, is more complex than any conspiracy theory. This isn't just a story about sinister corporations suppressing genius. It's a story about the intersection of a revolutionary idea with astonishing technical challenges, deeply entrenched economic interests, and the unwieldy nature of large systems. Perhaps Smokey Yunick's engine was simply too good for its time, too radical, too expensive to implement, too dangerous in its potential disruptiveness to the established order. And yet, even without entering mass production, the principles laid down by Smokey Yunick didn't disappear without a trace. Today, engineers worldwide continue to research and implement ideas he formulated decades ago. Modern gasoline direct injection, GDI engines, the pursuit of lean combustion, homogenization of the fuel-air mixture, all are echoes of that very hot vapor. Yunick was a prophet, an engineer who was decades ahead of his time. His engine became not just a story of missed opportunities, but an archetype, a symbol of the eternal struggle between breakthrough innovation and those invisible yet powerful forces, economic, political, technological, and sometimes simply the inertia of thought, that prefer stability over disruption. Smokey Yunick's story is a reminder that the path of an innovator is never easy. Sometimes, to change the world, it's not enough to be a genius. You also have to conquer the world. And in this great war for the future, Yunick may have lost the battle for mass production, but his ideas continue to whisper to us about what our world could have been. Smokey Yunick's battle may have ended in defeat on the battlegrounds of the automotive industry, but his ideas didn't vanish into oblivion. They merely lay dormant, like seeds awaiting their hour. Today, decades later, the echo of his genius is clearly audible in every modern engine striving for efficiency and cleanliness. His hot vapor was not just a curious experiment, but a harbinger of the future, laid down by a genius whom the world then couldn't or wouldn't accept. Look into the heart of modern direct fuel injection engines, GDI, DFI. What do they strive to do? Atomize gasoline as finely as possible, practically turning it into a mist. Why? To achieve more complete, cleaner combustion. Isn't this a direct path to what Smokey Yunick attempted to achieve, only through more gentle methods? He aimed for complete vaporization, for the creation of an ideal, homogeneous mixture operating on lean fuel. This principle, homogenization, of the fuel-air mixture, lean combustion, and efficient vaporization, remains the holy grail for engineers. GDI engines use incredibly high pressure, up to several hundred bar, to transform liquid fuel into an aerosol-like substance, bringing it as close as possible to the desired vaporous state. They are seeking that very hot mist Yunick spoke of, while avoiding the dangerous heating of the entire fuel volume. Smokey, this bearded prophet from the best damn garage in town, was a visionary engineer who pushed every idea to its limit, often balancing on the edge of what was permissible or beyond it. His uncompromising character, his open disregard for NASCAR rules and systemic approaches he often called idiocy, were part of his legend. But this very character, perhaps, became one of the invisible barriers to his revolution. He, it is said, personally approached the largest automotive corporations, offering his engineering masterpiece amidst the oil crises of the 70s, when the world was gasping from fuel shortages, and each time he was rejected. Excessive danger, complexity, cold start problems, the official excuses. But wasn't there another, more fundamental fear lurking behind them? Fear of a man who didn't play by the rules. Fear of a system that didn't fit into their well-ordered world. The story of his hot vapor is much more than just a tale of a missed opportunity. It is an archetypal drama, playing out again and again in the arena of innovation. A drama about how breakthrough technology, capable of changing the world, faces not only technical challenges, but also an insurmountable wall of economic interests, political inertia, and deeply entrenched structural barriers. Oil giants, automakers with billions in investments in existing factories, a complex network of suppliers and service centers, all of them form the most powerful status quo. To change it means not just modifying an engine, but rewriting the rules of the game, reconfiguring entire industries, risking colossal assets. An innovation that threatens the very foundation of these systems often meets not open arms, but deaf resistance. That's why we see Yunick's ideas seeping into the modern world gradually, evolutionarily, not revolutionarily. No one built an engine completely replicating his vapor approach. Instead, engineers cautiously, step by step, implement his principles, adapting them to existing infrastructure and technologies. This is a slow but inevitable process, confirming Smokey's genius. He saw what the world would only arrive at decades later, but he couldn't find a mechanism to put this visionary idea into the hands of the mass consumer. So, what is the price of innovation? Smokey Yunick's story is a powerful reminder that it can be incredibly high, not just in money and resources, but in missed opportunities for all humanity. It's a reminder that a prophet is often without honor in his own country, especially when his prophecies are too radical and too loudly contradict the established order. Smokey Yunick lost the battle for mass production, but won the war for ideas. His legacy isn't a mythical mileage or a rejected engine. His legacy is the eternal pursuit of perfection that continues to this day. And his story is a lesson for anyone who dares to challenge a world not always ready for abrupt change. His whisper continues to resonate in the hum of modern engines. There's always a better way. And we, looking under the hood of the future, are still trying to find it. The saga of Smokey Yunick and his hot vapor engine transcends simple engineering. It is an enduring parable of audacious innovation, clashing with the unyielding forces of centuries-old established orders. It is a story reminding us that true progress often contends not only with technical challenges, but also with the deeply ingrained inertia of systems unwilling to relinquish their power. In the pursuit of the future, we must ask ourselves, what truly defines progress? And how many more revolutionary whispers have been silenced by the very world they sought to save? Share your thoughts in the comments, subscribe to our channel so you don't miss new stories, and hit the like button if this tale made you think.